So today is the second class of classification of element and periodicity in properties of elements. So in this class, we will know about the modern periodic table. How this modern periodic table has been arranged. So in our the previous class, you can see that basically we have known about the history of the periodic table, how the periodic table has been created, and how we came to the long periodic table. So the title is the modern periodic table. So this is the modern periodic table. So in this modern periodic table, we can see there are the uh, groups. So this is the groups, and this is the period actually designed. Okay. So whatever elements has elements has been discovered. So according to their atomic number, uh, so this element has been arranged in the groups and the periods. So this modern periodic tables actually contains the 18th group. So there is the 18. So this is the 18 groups, and this is the seventh period. So these seven periods and the 18 groups are there. But among these 18 modern periodic table, you can see there are the uh, uh, four block elements are present. That means that whatever elements are there, these elements actually uh, classified into the four block. One is the S block, second is the D block, third is the P block, and this is the F block. Okay, so this is actually a S block element. This the two block is the actually S block. So this is actually D block, and this is the P block, and this is a block. So this is the block elements, this is the D block, and this is the S block, and this is the P block. So whatever elements are present here, so these elements actually has been classified into the four block S, D, P, F. So how actually they have classified this S block, D block, P block, F block. So we will later know actually. Actually, we will know that uh, the last electrons in which orbitals atoms, as we know that atoms has the S, P, D, F orbitals. Okay. So the last electrons of this element is present in which orbitals. So based upon actually this element has been classified. This is the S block element, this is the D block element, this is the P block element, and this is the F block element. So this modern periodic table has the four block S, D, P, and the F block, and it has the seven periods and the 18 groups. So there are the different metal. So this metal actually has the name. Okay. So in the previous slide, we can and see that this is the S block. Okay. So this is the S block. So this is the D block, and this is the P block, and this is the F block. Okay. So if you see, you can see that uh, first of all, this S block element. So there is the actually two groups. Uh, so these two groups actually, first two groups is called the S block element. Is the one and the two. But this first group element is the hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. So these actually elements is called the alkali metal. This element is called the alkali metal. Second group element is called the alkaline earth metal. Okay, so these actually elements is slightly basic actually compared to this alkali metal. That's why it is called alkaline earth metals. Okay, second thing, the groups are to groups 12. Okay, groups 3 to groups 12. So this element actually scandium to zinc. Okay, cadmium to zinc. So this element actually is called the transition metal. Okay. So this is actually 3D transition metal. This is 4D, this is the 5D, and this is the and this element actually called this lanthanide and the actinide. So we are not going that far. Okay. So we will know only the 3D metals, 4D metals, and this 5D metals. And this 3D, 4D, 5D, this metal. So this is the 3D, this is the 4D, and this is the 5D. So these three periods metal actually called the transition metal. Okay. Second thing. Second thing is that we know that 13 to 18. Okay. So this 13 to 18 is called this P block element. Okay. So among this 13 to 18, you can see 13 to 17. That portion, this 13 to 17, that is called actually main group. Okay. So this is the main group. And this the 18 is called the noble gas. Okay. So this is the noble gas. So among this main group element, this seven, this 17, this 17 groups element, fluorine, chlorine, bromine, iodine, uh, this element is called halogen. This element is called this halogen. Okay. So first of all, first group is called the alkali metal. Second is alkaline earth metal. R to 12 is called transition metal. 13 to 17 is called main group. 18 is called noble gas. And among this main group, 17 groups element is called this halogen. Now, this A block element, this A block element has the elements, whatever elements is there, cerium to lutetium. This element is called the lanthanide series element, and second is called this actinide series element. Actually, these A block elements actually present in that position. This is the lanthanum, this is the actinides. Okay, so here actually series actually is started. This 17, you can see that this is the 17, 18 to 71. Okay, so 58 to 71, this is called the lanthanide. Uh, then the 72 to again the 3D metal is sorry, again the transition metal is starting. Second thing is that actinides, this 90 to 103, this element is called the actinide series. Uh, then the 104, again the 104 to the transition metal is started. So here there are the different types of metals are the present, elements are the present. First of all, it is called the alkali metal. This is the alkaline earth metal. This is the transition metal. Halogens, this is the main groups. This is the noble gas, and this is the lanthanides and the actinides. Now the second slide. So in the modern periodic tables, what we have known till now, there are the seven periods, 18 groups, alkali metal, art alkaline metal, what element is that? Okay, so that's and this element, what is called this element? This is the transition state element, this is the noble gas element that actually we have known. But in this slide, what we will know the overall idea. That means that this first two, we know that this is the S block. This is the S block. Okay. So this actually elements, this element is called the main groups elements. Okay. What is said? Actually, this is a meta. This is the main groups element, and this is also main groups element. This is the transition metals, and this is the rare earth elements. So this is the rare earth elements. That means that based upon the broad class, we have actually classified this element into the three groups. One is the main groups element. This is the transition metal element. This is the rare earth element. Rare earth, that means that uh, in our world, this element actually are found very rarely. Okay, the amount of this, actually this element is very less. That's why it is called actually rare earth element. Second thing, it is a very interesting in this slide. You can see that we know that in the physical properties of an element. Uh, uh, so if I give the sodium, if I give the potassium, suppose if I give the cobalt, uh, so so to see this sodium, to see this potassium, we can also see that the physical properties is the solid. Okay, this physical properties is the solid. This is the gas, some is the liquid. Okay, so according to the physical properties, we can say it is in solid state, it is in gaseous state, it is in liquid state. So similarly, we can classify this element. This is the non-metal, metals, and metalloids, and the noble gases. We know that metals means it is actually electronically by electrically conducted. Okay, the electrons can flow. Non-metals, it is opposite to this metal. Metalloids means that there are the some elements which will have uh, some metal characters, some non-metal characters. That's why it is called this metalloids. And noble gas, that means this is gaseous element actually are inert. They cannot react with this another element. They are the happy with to each other. Okay, so they do not want to interact with these other people. So that's why this is actually inert gases. Somewhere it is called this inert gases. Somewhere it is called this noble gases. Okay, so in this periodic table also there are some non-metals, some metals, some metalloids, and some noble gases. Okay, so which elements actually are the non-metals? Which elements are the metals and metalloids and noble gas? We'll know here. So first element is the hydrogen. Okay, this is the non-metal. We know that this hydrogen is a gas. So this is the non-metal. So with this hydrogen, carbon, nitrogen, oxygen, fluorine, chlorine, bromine, iodine, phosphorus, sulfur, selenium, these all are actually non-metals. Okay, and we know that this the 18 groups element are the noble gases. Okay, what is that? If I remove if I remove this, okay, so this helium, sorry, this helium, neon, argon, krypton, xenon, and Rn. So this element actually is called noble gases or the inert gases element. Okay. So these are the non-metal, these are the noble gases, and these are this boron, silicon, germanium, arsenic, tellurium. So this element actually the metalloids, because this element has the some metal characters, also some the non-metal character. That's why it is called these metalloids. Boron is the metalloids, not the metal. So apart from this non-metal, noble gas, and the metalloid, other elements is the lithium, sodium, potassium, rubidium, cesium, manganese, chromium, cobalt, nickel. So these all are the metals. So from this slide, you can see that most of the elements of the periodic tables is the metals. Uh, some elements are the metalloids, some are the non-metals, some are the noble gases. First, but most of the elements are actually metals. So features of the long form of the periodic tables. So in this periodic tables, there are the some features. First features is that it contains the element arranged in increasing order of the atomic number. Okay. So whatever elements you can see that. Uh, so suppose if I one, one, two, three, four, five, six, seven. If I see that this is a fourth number group, sorry, fourth number periods. If you see the salt, potassium, calcium, scandium, titanium, vanadium, chromium, manganese. So it is actually arranged according to this atomic number. Uh, 19 to 20, 21, 22, 23, 24, 25. So that when the atomic number is increased, yeah, and this element actually arranges according to this increasing the atomic number. Okay, so this is the first point. Okay, so it contains the element the arranged in increasing the order of the atomic number. Second point is explain the position of an element in relation to other elements. So what is that? something is that suppose the potassium and the rubidiums both are actually alkali metals. So there is the relations between this potassium, then the rubidium, then the cesium. So all the elements are actually alkali metals. So there is a relation. That's why these all are present in the same group. Second, consists of the groups and the periods. So this is actually main actually achievement of this periodic table, that we can arrange, but we can find out easily of an element according to his or its the groups and its periods. Suppose I want to know that this is the nickel. Okay, so four nickel is present four periods, and this is the group number is uh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the 10. So 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 nickel is present fourth period and 10th group. Okay. So this is actually for the nickel. So in this way, actually we can actually find out this element. So this is actually great achievement of this long form of the periodic table. Second thing is that we know that there is the groups and there is the periods. We know that there is the 18 groups, but but this 18 groups also classified is the A B groups. So 1A to this 7A, this is the one part. Another is the 1B to 7B. This is the another part. This is the 8 is the another groups, and 0 is the another group. If you see this periodic table, this is the 1A, 2A, 3A, 3B, and this is the 4B, 5B, 6B, and the 7B. And this is the 8B. So these are actually the 8B. Uh, so this actually 18th group is classified. This 18th group actually classified among this is to the subgroups. We can say this is the subgroup. Okay, the elements in a group have the similar, but they not the identical electronic configuration, but it has the similar electronic properties. Similar properties, but this electronic configuration are will be the different. Seven is a periods. There is the seven periods. We know that 1 to 7. So there is the no sub periods, and which contains the 2, 8, 8, 18, 18, 32, and the 18 elements. If you see first, this is the first period. This first period is contain these two elements, hydrogen and this helium. Second period is contained, there is the 8 elements. 1, 2, 3, 4, 5, 6, 7, 8. Third also is contain the 8 elements. So fourth also is contain the 18 elements. And this is the 5 also contain this 18 element. But the 6 is contain this 32 element, because there is the lanthanum is inserted. That's why it is actually like that. 2, 8, 8, 18, 18, 32, and 28. So whatever elements we can find out. So there is a this number of the elements are present in the modern periodic tables. But it is arranged according to the period. First period is present the 2 elements. Second period is present the 8 elements. Third period presents the 8 elements. Fourth period the 18 element. Five 18 element. Six 32 element. Seven 28 elements. Here the lanthanum and the actinides are the present. This the A block elements are inserted in this two period 6 and the 7. That's why the number of the elements also is high. So in this array, the modern periodic table actually have been created. Then the some features you can see, we already know that this modern periodic tables consist the metals, non-metal, and the metalloids. So again, here we will know that this is the presence on the left hand side of the periodic table. These all are the metals. These are the solid, these are the metal level, these are the conductors. What already I told that these are the conductors. Non-metals are present on the right hand side of the periodic table. Uh, these are solid. Some non-metal has a liquid, some are the gas. Like that, this is the chlorine, bromine. These are also the gases, but they are also the non-metals. But the metalloids, we know that it has the some characters of the metals and also the non-metals. That's why it is called the metalloids, like the boron, silicon, germanium, arsenic. So these all are the presents in the zigzag position. So this is the zigzag position. You can see that then you see the zigzag position. So in that zigzag position actually present this metalloid. Okay. So these are all other metalloids. Now already in the second slide, we know that the elements has been classified in the fourth block, the S block, P block, and the D block, and the A block. Now we will know why we are saying this element is called this S block element, why it is calling the P block and the D block and the A block elements. Because this is actually maintained is that in this array on the basis of the nature of the subcell in which the last electron of an atom enters, and the elements are divided into these four blocks: S block, P block, D block, and A block. We know that there is the S orbital, there is the P orbital, and there is the D orbital, uh, and there is the F orbital also is there. So we know that S, P, D, F. So these orbitals actually are presence of an atom, uh, and these atoms, this orbital also the contains the electrons. So we will find out that the last electron, uh, where actually this last electron the enters, in which orbitals this last electron is going. So according to that, actually, we have the classified this element into the four block elements. This is the S, P, D, and F. First of all, this S block element. Okay. So in this element, this last electrons enters the s orbitals. We know that s orbitals are the spherical. So in this s orbitals, actually, this last electrons is enters. Okay. So when the last electron is enters of this element, it is called the s block element. And what will be the electronic configuration of this s block element? NS1 and NS2. Okay. So S for the s block element and n is the principal quantum number. It is the S is the principal quantum number. Okay, so the electronic configuration will be the S1 and the NS2. NS1 is for this alkali metal or alkaline earth metal. It is for the NS2. So for this alkali metal, it will be the NS1, and for this alkaline earth metal, it will be the NS2. And all metals, and if you see in this group, so all are the metal S block element. If you see this S block element, okay. So these are the actually S block element. So these S block elements all are the actually the metals. So all are the metals which has the some the physical properties we will know the later. But here I have just point out this is the low ionization energy and the low melting point and low the boiling point, and these all are the electropositive elements. This is not actually electronegative. All are the electropositive elements, and compounds are the mostly the ionic and they are the colorless. Okay, like the sodium, potassium, salt. This is the NaCl. Okay, the KCl. This salt actually are the colorless. This is the white. So sodium, potassium, all are the present. Okay. So this actually alkali metal are the present. So contains these alkali metals, yeah, they are actually the colorless. So there is the two alkali metals and the alkaline earth metals. Uh, So the S block contains the alkali metal and the alkaline earth metals, which has the electronic configuration NS1 and NS2 respectively for the alkali metal NS1 and the alkaline earth metal NS2. Okay, these are the metals. It has the low ionization energy, low melting point, low boiling point, and they are the electropositive. Second is the p block element. If you see this p block element here, in this element, this last electron enters the p orbital. Okay, so s orbital is the filled up. So the last electron is going to the p orbital. So electronic configuration will be the ns2 and np1 to 6. How this actually happened? We know that s orbitals has maximum the two electrons will be present, and this p orbitals 6 electrons will be the present. Okay, so 6 electrons will be the present. So suppose the one element has the 3 electrons. Okay, so 2 electrons will be the s orbital, and last one electron will be the p orbital. So the electronic configuration will be the nh2 and this np1. So in this array, this p orbital can have can have the 6 electrons. That's why the general electron configuration is ns2 and np1 to 6. Okay. So for that actually p orbital, s orbital will be always the filled up with these 2 electrons. For the p orbital, some for the some element it will have the 1 electron or the 2 electron, 3 electron, 4 electron, 5 electron, 6 electron. That's why the general electronic configuration will be NS2, NP1 to 3. And the groups, if you see the groups, uh, third A2 and this the seventh A and the zero group elements, that means that 13 to 18 is actually the P block element. So this actually the P block element. In the second two slide, we can see that this actually the P block element. So this is actually the P block element. Okay. And this already we know that these are also the non-metals and these are also the electronegative. As fluorine, chlorine, bromine, iodine. So this element also are the present. So these are actually the electronegative. These are the not the electropositive. So electropositive and the S block are the present left side of the periodic table, and the P block and the electronegative elements present in the right side of the periodic tables. And these are the non-metals, and S block elements are the metals. And this actually form this covalent bond. Actually, if you see the S block element, they are actually form this ionic bond. They form actually ionic bond. But here they form actually covalent bond. That means this covalent compound. Now we'll know about the D block element. So for this D block element, you can see that this last electrons enters the D orbitals. Okay. And this element also called the transition metal. So we already know that the S orbitals NS NP already we have know. Okay. Now NSPD. Now the D orbital is coming here. So to count this electron, the last electrons when come to this D orbitals, then already the NS and the NP orbitals will be filled up. But we know that we know that for that 1s orbitals, then the 2s and the 2p orbitals, and 3s the 3s and the 3p and the 3d orbitals. Right. Then we will so this is the 4s orbital. If you see the electrons is actually first going to the 1s, then 2s, and then the 2p and 3s, and then the 4s and like that actually indirect. So 4s first, then the 3p and then the 3d. Okay. So in this array, these electrons will be the arranged. So the first, if you see this 4s and the 3d electrons, first is coming 4s orbitals. Then it is going to the d or 3d orbitals. So so the last electron, suppose the d orbitals will have the one electron, but this last electron, when coming to this d orbitals, before that, this 4s orbital is the full up with this 2 electron. That's why the general electronic configuration, if you see, The orbital always, the ns orbitals always will be the two electrons. It will actually the ns2, always the ns2. That means this forest orbital always the filled up. Then the d orbitals will be, then the d orbitals will have the one electron, two electron, three electron, up to the 10 electrons. Okay. So why I have actually cut this one? There is some reason. So if you see, uh, there is the some hectare. It is called the stabilization. Uh, when say d orbital is the half filled, when is d orbital is the half filled, then it is the most stable. That is means the 35 electronic configuration. Uh, when its d orbital is fulfilled, then it is also the most stable. That is the 3D10 configuration, electronic configuration. For that case, there is the two exceptional case. This is the 4s1 and 4s1. Okay, so that's why the general electronic configuration, if you see, for the every the transition element, 4s is filled up with this two electron. Then the d orbital is filled up by this 1111 electron. But for that chromium trace, if you see this chromium, it has the electronic atomic number is the 24. Okay, so for this general electronic configuration, it will have the 3d4 and this 4s2, because we know that these 4s orbitals will first the filled up. Yeah. But there is another possibility, 3d5 this 4s1. But this configuration, for that configuration, d orbital is the half filled, which is the most stable than that one. That's why that's why it is written in S1 to 2. Uh, that is for the chromium case. And if you see this copper case also, it has the electronic configuration 3D9. So for that 3D9, we will write down a 3D9 4s2 electronic configuration. But that is not, because there is the another possibility 3D10 4s1. So this is the more stable than that one. Uh, so there is the two exceptional. One is the copper and another is the chromium. For that case, the first this half filled will be the filled up. Okay, and the d orbital will be the full, because of the stability, because of the stability of this half filled and the full filled. That's why the electronic configuration, the general electronic configuration uh, of the D block element is n minus 1, D 1 to 10, and NS 1 to 2. Okay. And this group is 1B to 7B, and the 18 groups, that means that 3 to 12 groups. They are the variable balance, high melting points, and boiling points. They are colored compounds. They are the catalytic properties there. That means that this type of the element actually can participate in the catalytic reaction. Then we will know about the F block elements. So if you say in this case, in this element, this last electrons actually present, it's going to this F orbitals. Okay. So here we know that we known as this is the inner transition element, because if you see this F block is present in the transition element. Okay. So that's why it is called this inner transition elements, and the electronic configuration is n minus 2 f1 to 14. That means that actually F orbitals can have the maximum 1, 2, 3, 4, 5, 6, 14 electrons. That's why it is the 1 to 14. And these n minus 1d electrons will have the 0 to 1 electron, and ns will be the filled up always. This is the 6x2, always the 2 electrons. So that's why this is the general electronic configuration. You will have to know, and you will have to remember of this general electronic configuration. Present below the periodic tables, we know that this is the F block element. This is the F block elements, lanthanides and the actinides. And lanthanides elements after the lanthanum. This is the group 3 applied periodic tables here, period the 6. And actinides also the group the 3, and the period is the 7. And these F block elements have the high melting points and the high the boiling points. So in this way, we have the classified the elements into the S block, P block, D block, and the F block elements. How these elements so the S block and the P block elements, the transition metals, that means the D block elements, and the inner transition metals being on that is the F block element. This has the valence shell, and this actually anti periodic cell is incomplete. That means that there are the some valence shell is there. Uh, this valence shell actually not filled up by these electrons. At D block also we know that there are also some the valence shell. This actually not the completed. So S block and the P block element, this as the representative elements. Okay, so according to the general electronic configuration of the S and the P block element, that is the okay. But for the transition metal element and the inner transition metal element, there are the some the exceptional case according to this general electronic configuration. So for that, there are the some cases we will know the later. We have to the remember, and we have to the carefully see what is actually changing for that case. Now we will know about the some merits of this long form of the periodic table. So based on the more fundamental basis, the atomic number. Okay, so what is that? Atomic number you have to know the carefully. Okay, because this actually periodic tables, whatever elements are present, these elements actually arranged according to this atomic number. So you have to careful about the atomic number of this element. Okay, so and the position of an element is related to the electronic configuration of its atom. Already we have seen that S block element, P block element, D and F block elements because the position this element is present in S block. That means that class electron is present in the S orbital. P block, D block, F block. This last electron is present at P orbital, D orbital, and the F orbital. So, according to this electronic configuration, also we can say, okay, this element is present S block element. This is the P block element. This is the D block element. Okay, well, this is a great achievement. Due to the separation of the element into these groups and the dissimilar elements, this is the alkali metals and the coinage metal. That means actually the alkali and alkaline metal do not fall together. Okay, so there are some alkali metal and the alkaline the art metal. If you say these elements actually has some character, some the similar type of the character. So we can actually mix it up. But here, these elements actually has been arranged in this way. We cannot mix up these two types of the element, alkali metals and alkaline art metals. So this is a great achievement of this also the periodic table. So these are the merits. But there are some that demerit also is there. It is unable to include the lanthanides and these actinides in the main body. If you see the periodic tables, again, go to the periodic tables. If you see this, the A block elements, lanthanides and the actinides is the present below the periodic tables. So we uh, cannot arrange these A block elements inside the main periodic tables. So this is a demerits of the periodic table. Sorry. And another demerit is the problem of the position of the hydrogens in the table has not been solved completely. Because if you see this element actually, if you see this hydrogen element position, uh, first of all, if you see this S block element, this is the S block element, but this S block element, if you say this is the lithium to this rhenium, lithium to rhenium, that means this the 3 2 and this 4. These actually are metals. Okay, but it is a non-metal. But these non-metals, actually the another non-metals are the present here. Okay, so this hydrogen could be present here also, but it is present top of the non-metal groups. That's why the position of this hydrogen element is not a right. Okay, so it is a one type of the demerits of the modern periodic table. Second thing is that we know that S block, P block, D block, F block element is classification according to the last electron. Well, this last electron where it is the entering. If it is entering the S, then it is the S block element. It is entering the P, this is a P block element. But if you see this helium, the two electrons, so the electronic configuration is the 1s2. So it should be the present s block element, but it is actually not present in the s block element. So this is also a demerit. And helium is a different from this inert gas. Inert gas has the electronic configuration ns2 and p6, and they are not the active. That's why that is called the inert or the noble gases. But for that also, but this is the NP. But the helium has the electronic configuration the NS2, 1s2, but they are the placed in the same group. Okay, because here what is saying that helium and the inert gas both are the placed in the same group. But if you say this helium has the electronic configuration 1s2 and the inert gas has the electronic configuration ns2 np6, both the electronic configuration totally the different. Okay, so according to this rule, helium should be present in the s block element and the inert gas already the present in the p block element. So that's why it is one type of the demerits of the periodic table. So here we will know about the nomenclature of this element. Already we know that naming of the element, but there are the some elements which has the atomic number greater than the 100, which has the electronic number greater than the 100. It is not showing here. Uh, Greater than the 100. There are the some rule, like the IUPAC. So there are the some rule. Uh, we can put this rule for that elements which will have the greater than atomic number greater than 100. What is that? So for that zero digit, we will say nil. For that nil, we will put the n. For the one digit, we will name will be the an. For that, we will put the u. That means that first actually letter will be first the word will become here. Uh, so for the third, it is the tree. So the T will be came here. The quad Q will be there. Paint P will be there. X H will be there. 7 for shift, S will be there. 8 for off, O will be there. And 9 for in, E will be there. Okay. So the naming will be the digits name plus IUM. Okay. For case, for example, 115. 115. So this atomic number. Suppose the atomic number is 115. So one means this is the on. So on means this U. So U, so on plus on. So one on for this one number, another on for this another one number, plus 5. 5 for this paint. So this is the paint plus eon. So the naming will be on Pentium. Okay. The naming will be on Pentium. But the symbol, what will be the symbol? The symbol will be for this 115. The symbol will be on for this U is coming, another on the U is coming, and this for this paint, the P is coming. So the symbol will be capital U, and this the P. So in this array, we have to know the naming of the elements which will have the atomic number greater than 100. So here there is the elements actually which will have the atomic number 1012 118. Okay, greater than 100. Here we can see this is the naming, this is the symbol, uh, this is the symbol, and this is actually the naming of this element. Suppose the 102. So 1 for this on, 0 for this nil, 2 for this B, so and this on. So unilbium. And the symbol is UNB. Okay. So in this array, this nomenclature of these elements actually has been designed. Another the official name also we can see. This is the novelium. This is the rubenium, barium. So there are the some elements actually which has been the discovered this later. but no, this nomenclature of these elements has been designed in this way. So here I will stop the class. So what we have learned this from that class, we have learned about these modern periodic tables, how many groups and how many periods we have, and what's the element is block, P block, and the D block, and how they why and how this element actually has been classified. What is the alkali metal and these alkaline earth metals, non-metals, metalloid, and the transition metals, and then we have actually known about the electronic configuration of the general electronic configuration of the S block and this P block and the D block elements and the F block elements, and there is the some merits of the long from the periodic tables and some the demerits of the long from the periodic tables, and also it is the nomenclature rules, and this is the rule of the nomenclature where we can see the atomic numbers when the atomic numbers of the elements is greater than the 100, then what rule we have to they apply for that elements, and this is the another the elements which actually has been discovered this later. So here I will stop the this class. So next we will know about the physical and the chemical properties of that elements in the third class. Thank you very much.